Thanks for joining us for the definitive deep dive into the .git folder. I'm sure we'll have others who join us in a few minutes, and that is totally fine as well. I suspect you'll be able to watch the recording. In this session, we are going to open up every file inside the .git folder and talk about what it does. Here's the part where I tell you I am definitely going to post the slides on my site tonight. But in this session, there are no slides. But we can grab all the resources here up on GitHub. We can go to github.com/robrich, and I just posted that link in chat because that's quite a long URL. But if you're trying to get here, let's go to robrich.org. Here on robrich.org, click on presentations, and here's the definitive deep dive into the .git folder. The link to the gist is available online right now. While we're here at robrich.org, let's click on About Me, and we'll see some of the things that I've done recently. I'm a Microsoft MVP, a Docker captain, and a friend of Redgate. I'm also a Cyril developer advocate. If you're struggling with your data mesh, I would love to learn from you. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here in Philadelphia or wherever you're connecting from, hit me up on email or Twitter, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, Pro Microservices in .NET 6 is a brand new book. I got to work with Sean and Matthew Groves on this. You can grab that. It's really fun to dig into .NET 6. Some of the other things that I've done, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. So let's go build up some Git history. I have here a completely empty folder. Well, actually, no. Here, I have a completely empty folder. And we want to turn this into a Git repository. So we could say git clone https github.com. And that would definitely work, but let's not do it that way. Instead, let's do this, git init. Now, once I've created this folder, if I come here into this folder, I now see I have a .git folder. Now, depending on your options, you may need to go into your view settings and turn on hidden files and folders. In Linux and Mac, it is hidden because it starts with a dot. So you might have to do an ls-la to be able to see the .git folder. But this is the .git folder, and we're going to dig into all of its content. So let's pop open this folder inside of VS Code and take a look around. Here we can see, and I'm specifically opening the .git folder and not the folder that it contains because VS Code hides the .git folder from us, which is perfect in most situations. So we see lots of content. We have refs, objects, info, hooks. Let's build up some Git history so that we can poke at this a little bit. I'm going to say echo file1 contents, and I'm going to echo that into file1.txt. Okay, now I've got a file inside my directory. Let's git add this to the staging area, file1.txt, and then let's git commit-m file1 commit message, and now we've committed that to source control. If we look at it, we've still got that file1. If we do a git log, we can see that we've got that one commit. Here's this commit hash 131719. And so if we look here in this .git folder, let's first take a look at objects. Now that's interesting. We now have a 13 folder. That was the first few digits of our git hash. And inside that, 1719. This is the file that is that commit. Now, it's zlib compressed, so we need to uncompress it. Now, how might we do that? Well, there's various ways that we can unzlib compress things, undeflate things. Here's a Git, a Stack Overflow post that you'll find on that GitHub gist. We could use Perl. We could use OpenSSL. That's a really cool use of OpenSSL to unzlib compress things. Here's a little Python script, a way to do it with Git tools. I wrote myself this little program called Unzipper. And so let's go look at Unzipper. And Unzipper will just go read the file and use the zlib inflate library to be able to go read its contents. I split it by nulls just so that we can see all of the content and not just the digit to the first null. And then I just log that content. So let's unzipper this file. So unzipper, I'm going to get into the .git folder and into objects and into the 1.3 folder, and let's unzipper this object. So it looks like I have this content. It's a commit. I have 193 bytes in this message. It references a tree node. It has the author details and committer details, which in this case are both me. So here's my name and email, the date and time zone. And so we've got a lot of content here about that commit. Now it does reference this tree node, AD88CA. I noticed that there was an AD folder here, 88CA. Let's see if we can look at that one too. So let's unzipper that .git objects AD. And we can see that it is a tree node that has 37 bytes. It talks about file 1. And then it has some other stuff that is, well, double zlib compressed. That's kind of interesting. So let's use Git tools to be able to take a look at this. We can do git cat file. And with cat file, we can take a look at two different things. We could look at -t to look at its type. So let's look at the type of 1317, and that is a commit. Or we can look at the contents. So let's do a -p 1317, and now we see the contents of that commit. Now it excluded the commit and the bytes and only just showed us that content. That's fine. Git cat file -t for this tree node, and we'll see that it is indeed a tree node. And if we cat file -p that, then here's the contents. It specifies that file 1 was in the working directory at this commit. And here's the blob, the contents of that commit. So git cat file -t, it is a blob. Git cat file -p, and here are the contents of that blob. So when we created this commit, we actually ended up with 3 nodes, 3 objects inside of our folder. The first object, 1317, is that commit node that references the tree node, AD88, and finally the blob node, F3CF. Well, that's pretty cool. Let's do another commit, see if we get similar results. So I'm going to say echo file2, and I'll redirect that to file2.txt. Git add file2, git commit -m file2. And now we've committed that. If I do a git log, I see I have that original commit. I also have this new commit, C1FA. And looking in my objects folder, I now see I have a C1FA. And that probably references, let's do it, git cat file on C1FA. We'll do -p, it is a commit. So that references this tree node, git cat file -p. That one, it references the original file 1. Notice that's that same blob, but it also references this one, git cat file -p. That one, and so here's the contents of file 2. Now that takes kind of a lot to be able to browse through all of these objects, understand which ones are commit nodes and which ones are tree nodes, which ones are blob nodes. So let's see if we can do that a little bit easier. So I wrote this program here called Getexplorer. It's up on GitHub, github.com/robrich/Getexplorer, and you'll find that right at the top here in this gist. This Getexplorer allows us to be able to browse through the .git folder in the objects. So I've got this website, and it's going to visualize those commits. Right now we have 6 objects inside of our .git folder. So let's show the type. Here's the commit nodes. Here's this one that is this commit, and here's the other commit. And now let's show some tags on it. Actually, let's do this alphabetically, and then let's show the tags. Now I can see each of those things and I can click through it. Okay, here's this one and it references 9193. So here's that tree node. It references both F3 and C6. So here's this one, 6C rather, and F3. And so I can see file 2 contents and file 3. Let's switch from alphabetical mode to parent-child mode, and let's show the lines. And now I can see those references. I'll show the tags as well. So now I can see here's the latest commit, and it references this parent commit here. It also references this tree node that specifies all of the files in the working directory. And I get blob nodes that reference each of those pieces. So let's add some more files. I'm going to echo file 3, and I'll send that to file3.txt. And let's go refresh that. Do we have any changes in our content? Nope, we just still have those 6 nodes. OK, let's git add file 3. And now that I've added that to my staging area, if we refresh this, we see we have a 7th piece. Let's show the type, parent-child, show the lines, show the tags. Here's that commit. Now, it's not a commit, it's just the blob, but it is an object inside of our objects folder. We've already added this to our staging area. OK, so let's commit this, git commit -m file 3. And now that we've committed that, let's refresh this again. We'll show the type, parent-child, show the lines, show the tags. And now we see a 3rd commit that references this tree node. It has 3 files in it. And this tree node then references each of those blobs, including that new blob that we added to our staging area previously. So when we add it to our staging area, it adds this blob. That's perfect. We want to keep track of the file contents. If we're only adding portions of it, then we want to keep track of which portions of that file we added. Or if we add it to the staging area and then we change it farther, we want to keep track of the file at the state where we added it. So that's why we add it at the point where we add it to the staging area. Then once we commit it, it grabs the commit information, including the parent and all the files in the working directory, and we end up with something like this. That's great. So what happens if we add something into a folder? So I'm going to create a new folder here. We'll call this new folder. Let's call this folder. And I'm going to add file2 into folder/file2. OK, let's git add folder/file2, git commit -m folder file2. And now that I've created this new commit, let's see what type of objects we have in here. I'll refresh this, show the type, parent-child, show the lines, show the tags. OK, so we have this new commit, and it references this parent commit, our previous commit. That's great. It also references this tree node that specifies the things in my root directory, my working directory. So that's here. It also references this other tree node referencing this other folder right here. So let's cruise through to that other tree node, and that other tree node says I have file 2 in it. Now notice that I still only have 3 blobs. This new tree node references the original file 2 because, well, that's the exact same file 2. I don't need to add more content into my blobs if my file didn't change or if I just moved it or renamed it. That's what that tree node does, is keep track of the contents in this folder. So in this one, it says, by the way, I have a nested folder. And in this one, it says, here's the contents of this folder. OK, so let's do that some more. Echo file4. I'm going to redirect that to file4.txt. Now I'm coding along here inside file4, and I've got another function call and some code and an accidental secret and more code. And for all the Visual Basic people, here's some semicolons. So now I have my code, and I accidentally committed a secret. Let's see what happens. So I'm going to git add file4 git commit -m file 4. And now that I've got file 4 committed, if we take a look at our Git repository, let's refresh. Show the type, parent child, show the lines, show the tags. Here's our thing that references this new file. Oh, we accidentally committed a secret. Let's see if we can get that out. So let's pop open this file, and I'm going to remove this line of code. I definitely don't want the secret here. And now let's git add file 4. Now, as I'm doing a commit, file 4 changed. There is this amend. Now, amend is kind of like, let's rewrite the previous commit. So let's do that. We'll amend it. And if I say git log, and I'll do -1 line so that I only get just the content, we can see that we only have 5 commits. We have file 4, and it references the content above the folder. But let's refresh all of the content in our repository. Show the type, parent child, show the lines, show the tags. And we have this commit that is head, and its parent node is this one right here. In this working directory, we see that we have file 4 here. The blob is 486. So if we look at 486, we can see that our secret is removed. But our original commit right here is still there. It references this tree node, which references this blob, which has the secret still in it. If you have committed a secret into your .git repository, whether you've pushed it or not, whether you've rebased it or not, whether you've amended it or not, whether you've git reset, you still have that secret in your .git folder. If you have pushed this repository, then other systems now also have that secret inside of the .git folder. If you commit a secret to Git, you should consider the secret lost, and you should roll the keys. I'm sorry, there's not really a way around that. If you commit it, it is committed, and so you need to roll the secrets. Any concerns or questions here about objects or the secrets that we've done? Great, so let's dig in. Now, right now we have a whole bunch of files here in our objects folder. We have a bunch of folders. Now, if you open up another repository, you may not have all of these files because periodically behind the scenes, Git is going to run a git gc. Git gc will go collect all of the unreferenced things and be able to remove that history out of your Git repository and also pack all of the content into pack files. Now, right now we don't have any pack files, and I'm going to wait a minute to be able to pack this, but we may see only one pack file that references all of this other content, and that's pretty cool. So we talked about objects. Next, let's talk about refs. Now, right now, when we do a git log --1 line, I'm going to do --graph and --decorate. We can see that we have head, and head points at main, and main is at this commit. So let's wander through our .git folder and see how that works. Ooh, we have this head file. Let's open up this head. It says that it points at a ref, and that ref is here in refs heads main. Oh, we have a refs folder. Let's open up heads. Ooh, there's a main file, and here is the commit that it points to. Now, we had some other commits, so if I say git log, and maybe I want to move main to this commit, I could come into this file and just paste that commit into place. Now, if we do a git log --1 line, we can see that main is moved to a different place. Now, we also just made a real big mess because we didn't pass go, we didn't collect $200, we just kind of lifted this branch and put it there. The only way that you can break Git is by changing files inside the .git folder, so let's undo that. Let's do this correctly. Now let's come back and we can see that now main is where it was. If we do a git status, everything is fine. I want to add a new branch. So let's say git branch, and I want to create a new branch right here. Now, as I created that new branch, actually, I did something really interesting. Git log --1 line. I forgot the parameter, so I created a branch named C1FA0E0. So here in our heads folder, we have this C1FA0E0. Let's delete that branch and try again. Git branch -d. I'm going to do a capital D because I want to delete it in spite of the fact that I may not have completely merged it. And let's git branch. I'm going to say new branch, and I will do that at commit C1FA0E0. Okay, now let's take a look at it. Here's my new branch, and it's pointing to this commit. Back in our refs folder, we see that the C1 is gone, and we have a new branch pointing at that commit. Our head is still pointing at main, though. We haven't moved our head to the other one. So let's check out this new branch. Git checkout new branch. And now if we take a look at our history, we can see that head points at new branch. In our head folder, it points at new branch points at this commit. Now what happened to our other content? We still have all of the objects here inside Git. We still have the main reference, but we're not seeing it in our history. Let's add one more parameter. Let's say --all. And that will show us not only the things in the current branch, but also things in other branches as well. There we go. We've got main. So what happens if we say git checkout? I'm going to check out this commit. Ooh, we got a wonderfully painful message. You are in a detached head state. So I took off my head. Halloween notwithstanding, this is a pretty scary message for a pretty benign concern. What it says here is that if we open up the head file, we can see that it points at a commit, not a ref. Now we can continue doing stuff. Let's say echo file 5 into file 5.txt, git add file 5, git commit -m file 5. Everything still works, but we don't have a reference pointing at this thing. So now if I say git checkout main, and then I do all of the things, now I don't have a reference to that commit anymore. Now that commit was B493, so if we come back in here to our visualizer and take a look at this, show the type, parent child, show the lines, show the tags. Here is that B3 commit. It's still there. Here's the tree, here's the blob. We just don't have a reference to it anymore. So in time, in 2 weeks or whenever git GC runs next, then it will go clean that up. And that's what it's telling us when it's in a detached head state, is that that commit may be gone if we don't create a branch for it. Okay, so let's come back to getting that commit back. Let's talk about remotes. I have here another folder, and this folder is also empty. I want to create a server here. We did a git init previously. I'm going to do a git init --bear. Now, right now, this folder is completely empty, but I want to make it a server. So when I say --bear, it will create a Git repository. We see all of the contents like we had, but we don't have a .git folder. Thus, we don't have a working directory. This is perfect for servers. So on the server, I don't need a working directory. I don't want to check out anything on the server. I just want to have all the Git content. Therefore, I have the server. Okay, so now here's this server folder inside the demo folder, and back here in our regular one, we want to git remote add. Now I can name mine. By convention, we might call it origin, but we could call it anything. And we could point it at https github.com. We're not going to do that. We could also git remote add origin it at some server. path to folder, and that could work, but we're not going to do that in this case. We could say git remote add origin c:/path to folder, give it an absolute path. In this case, we're not going to do that either. We're going to give it a relative path, git remote add origin, and we'll go up one folder to the server folder. Git remote -v, we can see our origin server points at these two things. We have different URLs for fetch and push if we needed them. In this case, we don't, so they're the same. So now let's git push origin main, or actually let's say new branch. Now when we push new branch to the server, here in the server's objects folder, what once was empty now has all that content. Similarly, in our local directory, we now have these objects. Now, we only pushed a few objects, so if we say git log --1line --graph --decorate --all, we see that we pushed new branch up to the server. So now we have another remote, or another branch. Let's come here into our refs, and we have a remotes folder. Excellent. Inside the remotes folder is an origin folder. Inside the origin folder is new branch. Here's new branch and where that points to. Now, in this case, new branch points to the same place as on my local machine because nobody else has pushed content to that branch. Let's push other branches. Git push origin main. Okay, now that content from main is there, and here in our server folder we can see that it has lots of content. Actually, that's our local one. Here's our server folder, and it has a whole bunch of stuff. We have 16 items on the server, and we have 21 items on the client, because we have that one commit out in the that we did on a detached head that we need to go find. Okay, let's do tags as well. I want to take a look at this, and I'm going to say git tag v0.1 to main, where the current head is. Okay, so let's git log --1line --graph --decorate --all. We now have this tag. Here in our refs folder, we have a new tags folder, and this tag points to where that commit was. In this case, the tag v0.1, thanks VS Code, points at this particular commit. And we can choose to push our tags to the server too. Git push origin --tags. And now on the server, let's come back to the server. In their refs folder, they also have a reference to this tag. So here in our Git folder, we took a look at objects, how it stores commits, trees, and blobs. We saw refs, how it references human readable labels into those things. Next, let's take a look at logs. Now, this is the heads log, and we can see that it started here, and then it went there, and then it went from there to here, and it went from here to there. And we also have logs for our other heads and remotes as well. So for example, the main branch moved like this, and new branch moved like this. Now we can browse this log of our refs using git reflog. So git reflog, git reflog. I can see a cat of nine tails. Git reflog, or if it helps you to remember it, reflog. Now we want to go look for that file 5. Ooh, here's that file 5. That's the commit that we created that we did in a detached head state. We can use the reflog to go find it. Here's the commit that it was at. So let's git check out that commit. Now we have the scary message, but we understand completely what this says. We don't have a branch yet. So let's git check out. I'm going to say -b, which will both create and check out this branch. Missing commits. Git log --1line --graph --decorate --all. And we can now see that we have that new branch that we had missed before. Reflog is a great way to be able to find that. We also now have our head pointing at a real branch, so Git is a little bit less freaked out. And now we have that branch in place. If we wanted to push it to the server, git push origin missing commits. Now, it always bothered me that I'm saying origin missing commits. I wanted to push the missing commits branch to origin. Couldn't I just say git push missing commits to origin? Well, no, actually you can't. I'm going to say git push to origin the missing commits branch and the main branch and the new branch and tags. And so that's why the server is third and the branch is fourth, so that we could specify multiple branches if we wanted to. And it looks like in this case, everything was up to date. The server has everything that our client has, and we're ready to go. So we talked about Git GC. Let's run it. Now, Git GC runs behind the scenes anytime there is enough change in the repository to warrant it. So probably if you just found a commit that Git command that took a little bit of extra time to run, then it was probably doing a Git GC behind the scenes. So we enumerated all of our objects, and now if we take a look at our .git folder, oh, that's not the right one. We take a look at our .git folder, we can see that inside of our objects folder, there's a lot fewer things. Inside of our pack folder, we have this two files. One is the index file, and one is the actual pack file. That's pretty cool. If we look at our refs is a little bit emptier because all of those are packed into the pack file as well. Now that this is up, let's close it. And so we packed that content inside the pack file. Now let's go refresh this and see if our secret is still there. Refresh. It's now looping through the pack file, which takes it a little bit of extra time. There we go. Show type, parent child, show the lines, show the tags, and we have our missing commit, which is excellent. We have main, that's perfect. And we still have our file 4 that references this tree node, that references this. Can you hear me better now? Device settings. Can you hear me better now? Yes, microphone is back online. Excellent. It cuts in and out slightly, but we can hear you. I'm glad. Thank you for letting me know. Teams is wonderful with my machine. Just let me tell you. Okay, so we're talking about, next let's talk about hooks or automation. Now hooks are great. There are chances where we can hook into things that Git is doing and take actions. So here in the hooks folder, we have some sample files. Here's this bin sh, so it's a shell script, and it does some interesting things on an apply patch. Or we could take a look at commit message, where we get to do some things. Now each of these are samples, but if I were to rename this and remove the .sample part, then that would install this hook here in my repository. So I'm going to go grab some content. I'll just go grab a bunch of hooks that I have here, and we'll set them in place. And let's go take a look at those hooks. Now, in each of these hooks, I created a shell script that just echoes the contents, the arguments passed to it, so that we can see what hooks are involved. So we have a commit message hook, a post update hook, a pre-commit hook. Let's go play with these automation pieces and see what we can do. Now we could run these hooks in interesting places to validate commit messages, maybe to run unit tests, run our lint process, git checkout main. I'm going to say echo file6 to file6.txt, git add file6. So no hooks yet. Git commit -m file6. And now we see we've got the pre-commit hook, we've got the prepare commit message hook, we've got the commit message hook, and ultimately then we committed it. Now at each of these places we could do tasks like run unit tests, run automation, lint our code, validate the commit message to match our requirements for our release notes. And so we can do lots of interesting things. Git push origin main, and we can see that we've got the pre-push hook, and then it sent all that content up to the server. If ever you've used Kudu or other hosting platforms, DigitalOcean, you might see that after you git push, it does a whole bunch of stuff. Basically, they just hooked into the post commit hook and took action on the server. Git's webhooks are really similar. On each of these things, it'll call a URL, which will be pretty fun. So I've created all of these hooks, and I really like them. I want to say git add.git/hooks/pre-commit hook. I want to add that to my repository so I can share it with others. Git status. Nope. We can't commit content that goes inside the .git folder. That's a bummer. So what can we do? Well, here's Git Hooks. This is an NPM package that allows us to symlink from a .git hooks folder, that's their default, into the Git Hooks directory. Now, this isn't the only one. Here in these this list, we have Git Hooks, or we could use Husky. Python uses pre-commit, and lots of other languages, including C# likes the pre-commit package as well. In PHP, we have PHP Git Hooks or Grum PHP. Git Hooks or this gist inside of shell scripts. We could also use this Git Hooks in Go, which is a rewrite of this shell script, by the way. Or we could just create a configuration that links this into another place. Now, the bummer part about this one is that that configuration is also user specific, so we wouldn't be able to do it. I recommend Git Hooks or pre-commit because it's really elegant. So then we can symlink those automation scripts into a folder that we can commit, and now we can share them with the rest of our team. Hooks are really elegant for automation. So we looked at hooks. We looked at logs, objects, refs. Let's take a look at configuration. Now, our first configuration piece here is this config file. Now, this config file specifies the details for this repository. Now, these details actually override the details in my .git folder in my local directory. So let's open that one. Here's my .git config in my user profile. Remember when you said git config -- global and you set user.name and user.email? Here's where those values ended up. Now this is user specific, but it is called the global one because it's global for all repositories that you use. I'm not sure if I like the term global because it's not global to the machine. We have a third level called the system one that is in that spot where Git got installed. So in my case, it's in program files, Git, etc, Git config. These are all the settings I chose when I installed Git. And then I override that with any user-specific details that I put inside my .git config in my user profile, and I can further override those with any settings that I put inside this local repository. So let's say, for example, we need a local repository that is for work, but the majority of our content is free and open source using a personal account. So we have this config that says what is our name and email. Let's copy that. Let's set that right here in this repository specific one, and we'll change this to be company.com. Now this repository is specific to the company, and the other repositories are specific to my global setting here in my user profile. Now that doesn't change any of my existing commits. They still reference my old email address because that was the configuration when I created it. But if I do echo file 8 to file 8.txt, git add file 8, git commit -m file 8. Now in my new stuff, great to see that automation in place. That was cool. Let's take a look at git log, and we can see that my new commits have that new configuration details. Now we can set a lot here in this config file. Any setting in Git we can override here. So for example, I have some interesting things. Git log --one line --graph --decorate --all. That's a mouthful to remember. So I've taught myself that I can use git hist to accomplish that. Git hist, and it will just do all of that really nicely. Now that's an alias that I have set up on my local machine. I can't share that with the rest of the team, but if they put aliases in their .git config, then that can work out well as well. It references my GitHub profile. It references my diff and merge settings. And then I also have this autocorrect, which is really cool. So what if I say git status? It says, I think you meant status. I'll just run that instead. That's excellent. The 0.8 here, or the 8 is tenths of a second. So it'll wait almost a second before it runs that command. I've also set up my default branch as main instead of master because Black Lives Matter. And so now I've got that set here in my user specific profile so that all the repositories I create will be created with a primary main branch. Now I definitely could put this in my Git config inside my program files, but if I were to reinstall Git, it would overwrite that. And so I really want it here in my user specific directory. It'll take effect for all of the Git repositories I create, and that will work out great. Now, I also have an alias here that I find really interesting. It's not unusual that I'll say Git, and then I'll go look at some reference material maybe, or start coding a bit, and then I'll come back here and I'll say Git status. So I have an alias here that very specifically says, if you get a Git command called Git, then run Git from a shell, passing in the rest of the arguments. So what's elegant about this alias is I can do something like git status. And it'll go, okay, I can help you with that. Aliases are really fun. Aliases are powerful enough that you could kind of rewrite the Git experience to make it feel more like TFS or SVN. Please avoid that. But it can be really powerful in creating shortcuts for you to be able to accomplish frequently used tasks where you don't want to type out all of the things. So Git config is wonderful. As we look through other configuration details here in our repository, we see that we have this exclude file. Now we could exclude things like in a .NET project, the bin and obj folders, the debug and release folders. Now, if we set them here inside this exclude file, then we will exclude them, but we can't check in this exclude file. It is inside the .git folder. So let's not set it here. Let's instead set it in a .git config file. Echo bin to .git config, or git ignore rather. And now here in this .git ignore file, we can exclude all of that content. And the beauty here is because we've got this now outside of our .git folder, we can commit it. Let's git add the .git ignore and git commit -m add git ignore, and that commit is in place as well. So there is an exclude file here. I would recommend not using it. Another configuration here is description. Git has a built-in web server, Git InstaWeb. And this is the description that shows up when you use Git InstaWeb. I bet you've never used it. You've used GitHub or Bitbucket or GitLab. It doesn't work very well on Windows, but on Linux, yes, Git has a built-in web server. And this is the description. Next, let's take a look at temp files. We have packed refs. Actually, we have commit edit message. We might have some other temp files here inside of, where is it? Refs, no, not there. Objects, info might include some temp files. And then we also have this index file. Now this index file is binary, but it specifies all of the details in our working directory. Now how might we read this? We could go look at this Stack Overflow post that talks about the contents of this index file, and in particular its structure, and it's pretty intense. If you want a program that isn't a Git tool, then here's Gin, a Python program that allows you to parse that index file. But as pointed out in this entry, there also is this Git command called Git Ls Files. So let's run that instead. Git Ls Files, and we'll do a -- stage, which will show us this merge status. So right now we're not merging, so they're all 0. This is all of the hashes of all of the files in my working directory. So when I say git status, Git doesn't need to go traverse the tree and look through all of the commits and all of their tree nodes and did this. It has that quick cache to be able to go look at, here is the status, here's the hash of that file. It can quickly hash this file and see if it's changed. This index file is purely for performance reasons inside of our working directory, and it's a great way to keep track of what we've committed previously. So there's that index file. We've looked at the temp files associated with here. Here's packed refs. So those are all the refs packed into our pack objects. So that's pretty cool. In this case, fully peeled and sorted. That's cool. So we've looked at every file inside the .git directory. Now, it's really cool. This may be the first and last time you care about Git in this level of detail, but it's really nice to see how it works under the hood. Now, hopefully, maybe the staging directory, the staging area is less mysterious, and the difference between remotes and branches is less mysterious. And the configuration options and automation tools can be a little bit more accessible. You can grab a great summary of this here in Eric Potter's post. He did this great infographic kind of showing the different pieces and what groups they're part of. Another great post is this one, where it enumerates each of the files and talks about what each one does. You can get a reference to these as well as all of the other URLs that we grabbed here on this GitHub gist. And you can grab that gist from robrich.org/presentations. If you're watching this video later, hit me up on Twitter at @rob_rich, and let's continue the conversation. For those of us here at Philly Code Camp, what are your thoughts? What are your questions? What are things I should show next time I do this? One of the questions I often get here is, well, what is a remote tracking branch and how do I keep track of that? Exactly. A remote tracking branch is here in the refs folder. That's where branches are stored, and it's in this remotes folder. This is my remote tracking branch. It keeps track of where is this main branch on this server called origin. So if I were to delete this remote tracking branch, I would remove my reference to where that branch is on the server, but the server has its own set of branches. So if we flip back over to the server here and we look at the refs, it has its own copy of main. So if I delete this main, I'm not deleting the branch on the server, rather I'm only deleting my reference to that branch, thus a remote tracking branch. Well, excellent. It looks like there's no questions in chat. I had a lot of fun getting to share with you the contents of the .git folder. Hit me up on Twitter at rob_rich, and let's continue the conversation. Thanks, everyone.